Tonight, you reached for your phone before you even opened your eyes. You did not decide to do it. Your hand moved on its own, the way a hand moves toward warmth on a cold morning, the way fingers curl around a branch when your body senses a fall. That reflex did not come from nowhere. It came from 200,000 years of a brain learning that staying connected to your group was the difference between life and death. And your smartphone, without knowing it, has hijacked every single one of those ancient systems at once. Here is what no one tells you about your relationship with technology. It is not a bad habit. It is not laziness. It is not a generation getting weaker. Your brain is doing exactly what it evolved to do, and a small glass rectangle has learned to speak its oldest language fluently. Start with the simplest moment. You hear a notification sound, your pupils dilate slightly, your heart rate bumps upward, your attention snaps away from whatever you were doing and locks onto the source of the sound. This is not distraction, this is threat detection. Neuroscientist Matthew Lieberman at UCLA has spent decades studying the social brain, and his research shows that the same neural circuits that fire when you detect a predator fire when you sense a social signal. A ping, a buzz, a red dot on an icon. Your brain does not distinguish between a lion moving in the grass and a message arriving from someone in your network. Both demand immediate attention. Both could be critical. Your ancestors lived in groups of roughly 150 people. Anthropologist Robin Dunbar at Oxford first identified this number, now called Dunbar's number, as the cognitive limit of stable social relationships the human brain can maintain. In those groups, your survival depended entirely on your social standing. If you were excluded, you died. If you missed a critical piece of information, where the water moved, which plants were poisonous this season, who had formed a new alliance, you fell behind. You became vulnerable. So your brain evolved a dedicated system for monitoring social information at all times, constantly scanning, constantly updating, never fully at rest. Your smartphone is a 150-person social group that never sleeps and never stops broadcasting. Think about what happens when you open a social media app. You are not browsing content. Your brain is performing a social scan, the same scan your ancestors performed every morning when they woke in the camp and counted faces. Who is here? Who is missing? Who looks different? Who might be angry? Your eyes move differently on a social feed than they do on a landscape. Studies using eye-tracking technology show that human eyes fixate on faces in under 200 milliseconds, faster than conscious thought. Faces signal danger, alliance, status, and belonging. Your phone is a wall of faces, expressions, and social signals, updated in real time 24 hours a day. No wonder you cannot put it down. But it goes deeper than social monitoring. Your brain runs on a reward system built around dopamine, a chemical not of pleasure but of anticipation. Neuroscientist Wolfram Schultz at Cambridge spent years mapping the dopamine system and found something that changed how we understand motivation entirely. Dopamine does not spike when you get a reward. It spikes when you expect one, and it spikes hardest when the reward is unpredictable. Variable rewards, rewards that arrive sometimes but not always, that you cannot perfectly predict, produce the strongest dopamine response of all. Slot machines work this way. And so does your notification feed. Sometimes you open your phone and nothing interesting is there. Sometimes there is a message that changes your day. Your brain cannot know which one is coming, so it stays alert. It keeps checking. It is not addicted to the phone. It is running the same foraging loop your ancestors used to find food, probe the environment, check for reward, repeat. Here is where it gets genuinely strange. The brain does not only treat your phone as a social tool or a reward machine, it treats it as an extension of your own memory. Cognitive scientist Betsy Sparrow at Columbia University published research showing that when people know information is stored somewhere they can access, their brain stops bothering to remember it. Not because they are lazy, because that is rational. Your ancestors did the same thing. You did not memorize every plant in the forest. You memorized who in your group knew about plants. The group was your external memory system. You stored knowledge in people. Now you store knowledge in devices. Sparrow called this the Google effect, but the phenomenon is ancient. Your phone has become a cognitive prosthetic, a genuine extension of how your mind stores and retrieves information about the world. This is why losing your phone does not feel like losing an object. It feels like losing a piece of yourself. The anxiety is real. The disorientation is real. Your brain is registering the loss of a cognitive extension the same way it would register the loss of a limb, not metaphorically, neurologically. And then there is the question of status. In your ancestral group, status was visible and immediate. The person who brought back the most food, who resolved the most conflicts, who commanded the most attention, their position was tracked by every member of the group at all times. Status was survival. High status meant access to resources, protection, and reproductive opportunity. Low status meant the opposite, so your brain evolved to be obsessed with status signals, to notice them instantly, to respond to them emotionally and immediately. Now compress that dynamic onto a screen. Every like, every comment, every share, every view count is a public status signal in a social hierarchy your brain cannot distinguish from a real one. When a post performs well, your brain reads it as a status rise. When it is ignored, your brain reads it as social rejection. Psychologist Naomi Eisenberger at UCLA demonstrated that social rejection activates the same brain regions as physical pain. The anterior cingulate cortex lights up identically whether someone hits you or ignores you. Your brain did not evolve to understand that the stranger who scrolled past your photo is irrelevant to your actual safety. It only knows the signal. And the signal says, you were seen or you were not. This is why one bad comment can ruin a day that was otherwise fine. It is not sensitivity, it is biology, so what do you do with this? Knowing why your brain is doing something does not automatically free you from it, but it changes the relationship. When you reach for your phone at 2 a.m., you are not weak. You are an ancient social primate running ancient survival software in a world that has changed faster than evolution can track. The mismatch is not a personal failure. It is a design problem, a collision between hardware built for the savannah and software built for the attention economy. The companies that built these tools understand this mismatch very well. Former Google design ethicist Tristan Harris has argued publicly that the engineers who designed notification systems, infinite scroll, and variable reward loops studied the same neuroscience. They knew which levers to pull. They found the oldest pathways in your brain and they built roads directly to them. Your phone is not smarter than you. But it was designed by people who understood exactly how your brain works and who built a product that speaks to your deepest evolutionary instincts without you ever noticing. Which brings you back to this morning, before you opened your eyes, before you made a single conscious choice. Your hand had already moved. That is not a flaw in your character. That is 200,000 years of survival instinct meeting a device that has learned to sound exactly like everything your brain was built to pay attention to. The real question is not why you reach for it. The real question is, now that you know, what will you do next time your hand moves before your mind does?